G'day everyone, Dikko here with another kick-ass walkthrough. This is part 7 of a multi-part series that covers character rigging. In this video, we are going to talk about how to rig up the feet for the IK controls. So, in the previous video, we had already built out the legs. So the knees and legs and feet are all working as they are with the IK controls. With the FK controls, pretty simple setup. It's basically we just attach some controllers to the legs. So if we go to our little switch on the global control, you can see here, we just have a few very simple controls for the feet and legs. And that's pretty much all you need for the FK, sorry. But for the IK, you need a little bit more finesse, because not only is it in contact with the ground when you move the top half of the body, it kind of works independent from the rest of the body as well. So in order to sort of explain what I mean by this, it's best if I have a complete version of this foot setup that I on hand, and luckily I do. So let's check out my Eevee rig. So Eevee is a character from my short film or series of films that I'm planning on making or am making. I'm sure a bunch of you are familiar with this character already. But nice thing we have is a complete foot rig to work with. So let me just show you how it's built. So we have a global control that sort of has a pivot in the center of the foot. You can even have it at the heel if you wanted it to. Followed by this heel control, which lets you bank the foot from the heel, but also lets you bank it from the ball of the foot, which is really cool. All right. The other cool thing it lets you do is bank it from the sides of the feet. So from side to side, like so. The other cool thing about this rig is that it also has a toe pivot. So it lets you pivot from the toes if you need to rotate at a point on the tippy toes. And this is why having an IK foot rig like this is so useful to have, because you can have it pose in all kinds of different ways, while still having the sort of the world, like the overall control of the foot, just with a basic control like this. And of course, it works independent with the body. But when you move the global control, it moves as a whole. So that's what we want to try and build here. So we actually have, compared to the FK foot chain or foot rig, which is basically just two controls, one at the ankle, one at the toes, we're going to have 1, 2, 3, 4 controls for the foot alone. And that will give us all the control you would ever need, really, in my opinion, for a robust foot rig. So we're going to build that right into the Ragnar rig and basically build it in the exact same fashion. Now, this is a bit more complicated than your average foot rig, only because it requires a certain level of understanding of parent-child relationships, but also to do with the way that we're going to construct the drivers. So the drivers have a little bit more, they're a little bit more involved. So we'll get to that when we need to, but just be aware, it may take a few goes to understand what's going on here, but in the end, it's completely worth it. And I hope you are able to build something as good as this. So let's jump right in. All right, so let's quickly have a look and see actually what's happening underneath these controls inside of my Eevee rig. So if I switch back on my mechanism joints, my layers, all that sort of stuff, you'll see here that there's a bunch of different bones here that are controlling the foot. You'll see here that there is, a series of joints that are basically duplicates of my deformed rigs, which are, straining to the body. But then I also have, if I just turn on the octahedral view, you'll see that I have 2 bones that are going across the width of the foot and pivoting from each side. And then I have the same sort of setup of the from the ball of the foot to the heel, with 2 bones that are going in opposite directions as well. And this is basically helping me construct that that relationship of the pivot. So look how the foot is working here. So you can see here, as I rotate the heel of the foot, it actually activates the rotation once I hit a certain point in the rotation of that controller, which activates the heel rising on that control. And the same thing happens on the side foot banking. So if I were to rotate across the side, you'll see it rotates along with the controller until it gets to a certain point, which is basically the point of 0 rotation. And once it goes in the opposite rotation, it activates the other bone. And notice how that how this is working. So when I rotate this way, only one of the joints is following along with the foot. Whereas if I rotate it in the other way, the secondary joint is following along with the rotation there. And that's down to the way that our child-parent relationship with those bones are operating on a animation level or a driver level as well. Same thing's happening again with the heel. So when I rotate it a certain way, only one bone moves, and then when I rotate the other way, both bones move. That's because of the way that we've done the parent-child relationship. And again, same thing here. When I move the parent or the pivot of the top of the foot, the whole foot is moving with that single control. And then finally, when I move this global control, the whole thing is moving there. One thing to note is that with this rig setup, unlike other videos you may see on YouTube, this doesn't require any extra IK setup. It's purely parent-child relationships and drivers. All right. So what we need to do is replicate this relationship inside of our Ragnar rig. So we can do that with by taking a few notes of this setup here. So I'm going to write up a parent-child relationship list for you guys to follow, just to understand the logic of which joint is a child of which joint before we move on. And then we're going to link that all up with our Ragnar rig and then construct the drivers and controls around that. So let's move over to that list. Okay, so let's have a look at this diagram here. So using the Eevee rig as my base, before we jump into the Ragnar rig, we have a diagram on the left here that's just telling you what the parent-child relationships are for the joint chain. Again, it's quite complicated, but it does result in a very clean, efficient rig. All right, so starting from the global control here, we can see that it controls the entire rig. That is control_foot, followed by in the relationship, the control toe tip, so the toe tip here, and the control foot roll. So these are actually on the same hierarchy level. So these are actually the same, both parented or children of to the global control. And as you can see here, if I move this control around, that one works by moving both those controls, and these work independent of one another. These two controls work independently from one another. That's because they're on the same hierarchy. All right, so the interesting thing is that the rest of the hierarchy is pretty much controlled by the toe tip control. However, the rotations of the rest of these controls are driven by drivers controlled by the foot roll controller. All right, hope that is clear. I'm not sure, but that's what this diagram is for. All right, and you'll see here now that as we move down the joint chain, we have MCH, so mechanical joint, foot bank inner, which is this control here that pivots from the inside of the foot, is now a child of the toe tip, and that control is a parent of its outer partner. So the foot bank outer control is a child of this control here. All right, cool. Now foot heel rotation, which is this one here, is a child of this control, or this mechanism joint. All right, and then followed by the football roll, the football rotation. That football rotation is a child of this bone here. So you can see we're starting to get a very clear parent-child relationship going down the chain here. And then eventually, this control that we made in our Ragnar rig already last week, or in the last video, is a child of this heel control, or the football rig. Sorry, this ball control here. This one here is a child of this one here. All right, cool. And then finally, these controls, this control that we created is a parent of both the toe rig, the rest of the foot rig in the IK joint chain, which is what we have here. These ones here are a child of this guy here. For the foot rotation, so there's this independent little rotation here. This one's an independent control, which then drives that that heel. Okay, so now that we've explained the parent-child relationship of everything, it's now time to see where the drivers lie on these controls, because it's really important that you know which orientation it sits on. And you've got to be very aware of your joint orientation with the feet. So notice how the axes in my foot rig here are all pointing in a certain way. X is going this way, Z is up in this case with this rig, and Y is down. But notice that the controls also match the orientation. So the orientation of the controls have to match the orientation of the joints that are being used to drive the feet. So we have drivers that are being driven by this heel control across both the bank controls, the bank mechanisms here, see along the X, and the heel controls, or the heel mechanisms, okay? So be aware of that. In my case, I'm trying to keep it all on X with the drivers. And again, we'll get into that as we jump into the Ragnar rig. All right, let's get started. All right, so we're back with Ragnar. And you can see here that we've kind of got everything, the basic skeleton of what will become the foot rig up and running now. So we already have our mechanisms for the IK foot and toes. They're already a child of our, our shin control here. Okay, already a control. All right. So now all we need to do is build out the mechanism joints and the control joints that will actually control the rest of the foot. But first, let's turn on axes inside of the armature settings here. I want to see which direction everything is going, because I want to match it. I want to make sure it's all matching and it's all good. All right. So if the orientation of the foot is with the Z going down in your case, make sure that the rest of the joints are following that same orientation. If they're pointing up, that's okay. Just make sure that the orientation of your new joints are also pointing up. Okay. Let's get started. So to start off with, we're going to go into edit mode. We're just going to bring just the visibility of our IK controls at the moment. So we want everything to sit on the IK control layer at the moment. All right. I'm going to grab this control here and push Shift S, press to select it, and I'm going to create a new joint. Make sure I have individual origins turned on so I can scale that down. Switch over to hero. All right, cool. So this will become the global control for my foot. So I'm just going to set it down at the base of my foot, like so. And I'm going to name that control foot.l.001. All right, cool. All right, so now we need to make two more joints, one for the tip of the toes and one for the heel. So I'm going to create a duplicate of that and put it forward in space there. Duplicate that, drag it to the heel like so, and name that accordingly. So I'm going to call that foot, toe, tip, .l.001. And for the heel, I'm going to call that foot roll. You can call that heel if you wanted to, but I want to call it foot roll because it's actually manipulating more than just the heel. It's manipulating the banking as well. So call that foot roll. All right, cool. These are non-deforming joints, so we make sure they're non-deforming from the very beginning. So uncheck the form by holding down Alt and then uncheck the form. All right, so here comes the tricky part, all right? So these two controls are now a child of that middle control. So keep offset. Let's turn on our relationship lines so we can see what's going on. So these two controls are children of the global foot control, okay? And if we wanted to do this now before we forget, the global foot control is a child of the global control. And don't worry, I'll do the left side as well in a moment, or the right side. All right, cool. Let's mirror these across so we can do both at the same time. So I'm going to go to Armature, Symmetrize. And now we have the right side properly mirrored across with the right relationships as well. All right, cool. Let's jump back into just a single layer there. Go back to side view. And now what we need to do is start creating the banking of our foot. So you can see here we have our MCH bank inner. So if I bring back my diagram, MCH foot bank inner and foot bank outer. Let's do that relationship first now. All right, so what we're going to do, we're going to just duplicate this foot here, this control here, move that across to the side. Let's rename that now before we move on. Call that foot bank inner .L.001. Do the same thing for the right side, but with the right nomenclature. All right, cool. And we're going to rotate that along the Z in this case. So it sits at around that point there. All right, cool. Make sure it sort of lines up so it sits on that sort of banking area. And you can probably sit this across anywhere along the foot. So I'm going to put it a little bit forward at around where the ball of the foot is, or the toes are going to be rotating from. All right, cool. Let's duplicate that again. And I'm going to go to Armature, switch direction, and that will flip the bone. All right, cool. Let's rename that as foot bank outer .L.001. Do the same thing on this one. All right, cool. So I got our banking joints up and running. That's looking pretty good so far. All right, so what we need to do now is create a joint that goes this way from the ball of the foot, and then another one that goes this way. So what I'm going to do is extrude out from that base here along the Y, in this case, that way. And I'm going to call that, whoops, I'm going to call that foot ball rot .L.001. All right, do the same thing on the right side. And I'm going to duplicate that. And again, Armature, switch direction, and I'm going to rename that as heel rotation. .001. Make sure you're naming things appropriately as you go along. Okay, now finally, I think the only thing left to add as a extra bone is the control IK for the toes. So what we're going to do is grab this this MCH IK toes.L.001, duplicate that, and I'm just going to make it a little bit longer just so I can see what's going on, and I select it a little bit easier. And I'm going to rename that as control IK toes.L.001. Do the same thing on the right side. All right, cool. All right, finally, we're up to the point where we can start to work out the parent-child relationships of everything, make sure it's all linking up properly. So again, looking at the diagram I have here, so I want to make sure that everything is following that sort of that structure. So I'll just speak it out as I do it. So let's double check. I want I want the toes and the heel or the foot roll to be a child of the global control. And that's correct. Followed by, I want the foot bank inner, so this bone here, to be a child of the foot toe tip. Keep offset. All right. This bone here, control foot bank outer, is going to be a child of the foot bank inner. Keep offset. All right. All right. Now, followed by the heel. So MCH, IK, foot heel rotation .L.001 will be a child of the foot bank outer. Keep offset. Now just notice that I've named these incorrectly. I want to make sure that they are MCH bones, not control bones, because they're not control bones. Let's make sure that they're all named appropriately. Okay, yep, sweet. All right. Now this bone here, MCH, IK, football rotation .L.001 is a child of the foot heel rotation. All right, cool. Now we should be up and running with that mechanisms. Now, for the control IK toes, that is simply on the same level of rotation as the heel. So we want to make that a child of the heel rotation. So let's just do that. Hopefully that works. And we should be good to go. All right, cool. So if we go into pose mode now, you'll see that, and finally, this control here, MCH IK shin.002, that should be a child of the football rotation. So it should be a child of this one here. Keep that offset. All right, cool. So if we start to play with this now, it should be working all right. So the toes is moving pretty good. Notice how it's moving quite nicely. All right. If we move the entire controls, they're all moving appropriately. Good. Awesome. All right. And if we start to bank the inner control, the foot is banking in the right direction. Pretty good. If we bank the right side now, or the outer side, it's banking appropriately as you would want it to, just as we want to. Perfect. Now if we try to rotate the heel or the ball of foot, that's working too. Perfect. And now if we rotate the ball of foot or the heel itself, the whole thing's moving appropriately. So it's all there. The mechanism's all there. Finally, we have the toes, which is also will be moving the IK foot. So if we just go to pose mode now, we can actually add a constraint to the IK toes. So if we go to the control IK toes, select the MCH IK toes, Control C, copy transforms across to those. You'll see that this control will be doing its thing. That's correct, it's working, just as we want it to. So now you can see here that the heel is working as you'd expect to. All right, cool. So now all we need to do is build out the drivers to make this thing work. So what we need to do, we have to actually add a driver that has this control driving the rotation of both these controls here, like so, but also the banking along the different axes, like so. All right, so before we start working on the drivers, there's a few things that we have to be absolutely certain about, and that is the orientation of our joints. So I want all of my rotations to be controlled more or less through the x-axis of our mechanism bones here, all right? So the problem here at the moment is that they aren't rotating along the x-axis. So if I switch these over to to Euler, you'll see here that I'm actually rotating on the Z, and I don't want to do that. I want to keep it consistent. I want to rotate along the X. I mean, you could do it along the Z, but in my case, I just like to be consistent. I know that the main, my primary axis across my entire rig is X, so I want to keep it that way. So I want to make sure that it's the same across all of these as well. So that means I needed to change the role of these joints to match. So what I want to do is go to edit mode and adjust the role of my joints so that Z, you see the axis moving up here, is pointing up. So in this case, it's just 0 degrees with the roll. So I want to do the same thing on the other joint here, make that 0, so Z's pointing up there. I want to do the same thing here. So the roll is already correct in that case, and the roll in this case is also fine, so Z's pointing up there. So I want to make sure that the orientations are all exactly how I want them. And the same thing goes for these controls here. So let's just double check with my other rig, just to make sure that that is the same, and it is. So Y is pointing out this way. Let's have a look, double check again. So in this case, with this controller here, Z is pointing inwards in this one. So I want to do the same thing on my other rig. So make sure that the orientations are all correct. So when I rotate this along the x-axis, it will affect it in the same way along the x-axis or along these controls here. All right, sweet. That's all good and ready to go. So now all we need to do is start to work out the drivers. And you'll see here that with the way that this thing will work, you can see it's not affecting the rig at all at this point because there's no hierarchy to do it. The hierarchy all starts from the toes here, as you can see. All right, so there's one thing that you have to be aware of though. So what we want to do is be able to have the foot rotate up freely, but once it gets down to the ground, it can no longer rotate. So we actually have to add rotational limits in the driver to stop it from overextending down. As you can see, it starts to break the rig. Same thing goes with the heel. I want the heel, or the ball of the foot, to rotate up nice and easily, but once it gets down to 0, it can no longer influence the foot, otherwise it starts to break. So I want to do the same thing across the entire rig setup. And we can do that with drivers. Slightly more complicated drivers, but drivers nonetheless. We don't have to worry about doing it with constraints or limit rotations or any kind of that bullshit. So let's work out how these drivers function. Okay, so I've brought back my EV rig just to show you how these drivers are constructed, and they're quite interesting in the way that they're built. And it all plays into both the joint orientation or the bone orientation of my controller and of the mechanism bones themselves. So I'm going to just open up the driver panel just to show you how it's done. All right, so if I click on one of these mechanism bones, you'll see that I have a driver here. And if I were to make the driver more visible in the graph editor, you can see the driver is just a simple straight up expression. In this case, it's minus variance. But what's more interesting is the way I've done the driver graph. So you can see here, normally with a driver, when you build a driver, it has a linear value that goes both in negative and positive. But in my case, I've actually cut off the driver from functioning in the graph editor at the 0 point. So once it hits 0, it actually goes linear across 0 in negative values. And that's the same across all of these bones. And that plays into the function where we need to have it cut off, the rotation cut off at zero, at an angle of 0 degrees. All right. And notice how the driver is identical across all of these different setups. And that's because of the orientation of the joints are all the same, which makes it so much easier for us to manipulate the functionality of this rig. The only difference between these two controls along the heel and the ball of the foot and the banking is the rotation axis in which we act the driver upon. So for the heel and the ball of the foot, they're being driven by X rotation on this controller here, like so. And the ball of the foot, as in the banking of the foot, is controlled through the Z rotation of that controller. So if I rotate the Z in this case on this controller, it banks. So we're going to do the same functionality inside of our Ragnar rig. So let's go ahead and jump back into the Ragnar rig and do the same thing. So let's go into pose mode. And what we're going to do is add a driver. Well, firstly, we need to switch all of these different bones to a Euler or Euler rotation order. I'm just going to go with XYZ for now. You can push Alt and then click to select it and switch them all to XYZ, just like so. And because everything's operating on the X-axis as our primary axis, we're going to add a driver to the X-axis of these controllers. All right. So I'm going to add a driver. And I'm going to use the driver panel for this. I'm not going to use the quick driver toolset, because what I need to do is manipulate the actual graph of this driver. Okay. So I'm going to change the object to the armature, and it's going to be driven by the foot roll, and that can also be XYZ or Euler as well. All right, cool. So I'm going to copy that and put the name in there, and it's going to be driven by the X rotation in this case. We're going to set it to local space and auto Euler. All right, so let's just test this out to see if it's working for now. Let's rotate along the X. You can see here that it's doing its job. So the controller is actually manipulating the rotation of that heel control. The only problem now is one, it's rotating in the opposite direction that I would like, and two, there's no limits. So I can actually keep on going down, 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 and it actually breaks the rig. So what I need to do is go into this, firstly go into the driver, and I'm going to switch the variance expression to minus variance. So it will give me a negative value when I drive that driver. So firstly, now it should give me a negative value. So let me just put the negative value in there. Let's rotate that. And you can see now it feels a lot more natural when I rotate those controllers. But we're still getting that problem where the foot is breaking. You can see at the ankle, the foot separates from the ankle because we don't have a 0 value once we go too far. So what we need to do is go into this graph editor, and what I'm going to do is grab this handle here and move it across like so. So what I want to do is select all of these controllers here, push V and select free. So I want to change the handle type to free, and that will allow me to manipulate the handles individually like so. So what I want to do, I should be able to give this a value of 0 and 1. So if you go to the F curve, go to the left handle type, you can see here, frame, set that to -1 and the value to 0. So now we have the exact same pattern as what I had before. So now if I were to manipulate the rotation, you'll see that if I go into a positive value in this case, it's no longer affecting the rotation. But if we go into the negative, boom, it's doing its magic. How cool is that? So that's working just as we want. So now all we need to do is duplicate the same driver across to this controller or this mechanism bone. Copy that driver, paste it into the rotation X. And in this case, it might be the case where we have to add a positive value. So you can see here, it's not going to work like so. So what we need to do is manipulate this driver very slightly in the driver settings and change the expression from negative var to just var, variance. So now, if I rotate up, it's going to rotate up, rotate down. So now we have that limitation going on in the foot rig, and it's working exactly as we want to. How cool is that? All right. So now all we need to do to finish up this foot rig is do the same thing on the controllers for the heel bank or the foot bank. But in this case, what we're going to do is use the Z value on this control to manipulate the X value rotation of these controls or these mechanisms. So what I'm going to do first with this control foot roll.L, I'm going to lock off the rotation on the Y because I don't need that in this rig. And now what I'm going to do is essentially copy the driver again, copy this driver. And in this case, I'm going to go to first off our foot bank inner. I'm going to paste that into my X rotation. And in the driver settings for that X rotation, I'm going to switch it from the input variable from X rotation to Z rotation. So now, if I'm lucky and I rotate along Z, you'll see that it's rotating in the right fashion. How cool is that? Let's grab that driver. I want to copy that driver and do the same thing on the X rotation of the outer foot. But in this case, we're going to do the same thing we did with the heel and change the expression to a negative value, minus var. So now, if I rotate along the Z, I'm getting my foot banking. I'm getting my rotation on the heel and the banking, so that's up and running, doing exactly what we want. How cool is that setup? All right, so that's basically it. The foot's working. It's done. The only thing left to do is actually build out the control shapes because everything else is working exactly as we want it to. So you can see here it's doing its thing. The only problem here with this this toe is that you can't extend backwards on the toe. That's the only limitation with this rig setup here. And part of that is because we don't have any stretch controls on the IK. If we had stretch, it wouldn't really be a problem because it can just keep rotating. So in this case, if you wanted to, you could add a limit rotation on this. So if you wanted to add a limit rotation constraint on this guy, you could do so. So you can actually go to limit rotation, limit the X, make sure the maximum is, whatever you want it to be. Make sure it's local space, by the way. So you want to have, let's see, I want to have a positive. So I want to have a maximum positive of, maybe, I don't know, 90 degrees. So, and I want to make sure it's affecting the transform. So I can rotate along 90 degrees, but once I get to 0, I can't go any further. That's where you start to use this controller here. All right. All we got to do now is the right side. So again, same process. The only difference is that you may have to change the variance, but that's about it. So let's go ahead and copy that. Copy those constraints. I'll copy those drivers. Copy that driver to the same controller. In this case, we're going to paste it into the X again. But make sure that when you copy and paste the drivers, that you are pasting it and changing the nomenclature of the rig, like so. case, we're going to make sure that one's negative. Take dependencies, that should work. That one's working, that one's not working. All right, cool. Let's fix that up. var, there we go, that's better. That one's not working, all right. This one's the positive var, that's my bad. I just made a typo. There we go, that's working. As you want it to, perfect. I'm gonna copy that driver again. I'm gonna paste it on the inside. Change the rotation to Z. Make sure it's good. It's going in the wrong direction, so I can just make the variance expression to be a negative, and that will fix that. There we go, that's working. Copy this driver, paste it into the other foot, or the other side of the foot. Give that a positive expression. Save that. Boom. Working exactly as we want to, and again, it's working with the structure of the foot in mind. So that's working with the right side. Whole control's working there. Toes working there, as you'd expect. Add that limit rotation along the limit X, local space, maximum 90 degrees. And we've got that working as you'd expect. Perfect. The toes are now working. The heel is working. The banking is working. The global controls are working. And the toes are working. So that is that for the structure and mechanisms of our tow rig. So now all we need to do is hide away all those mechanism joints that we don't need. So we don't need any of these to be visible. So I'm going to hide all of these. Hide them away, except for that one. Let's see. Actually, what we're going to do, we're going to actually just, instead of doing that, we're going to actually copy the controllers and move those to a new layer. There we go. Grab those toes. Done. And we're going to move that to a controller up top. Awesome. I'm going to do the same thing for these controls up here, the IK pole vectors, because these are the only things we need to actually add some control shapes to. So now let's just see that all in action without any distractions. That's working. That's working. That's working. Perfect. That's working. Awesome. The banking is working. And the rotations are working. And in context with the rest of the rig, it's moving along as well. And you can manipulate and move the foot around, add a little bit of a bank, and you can see it's doing its thing. Perfect. So now all we need to do is build out the control shapes. All right, so let's get on with the shape, like the control shapes. And I'm not going to go through the process again. I'm just going to do a time lapse of the shapes I'm going to use. And you can use whatever shapes you like, as long as it's indicative of the function of the actual control or what the control is meant to do, then that's a good control shape. So, you know, you've seen me do this 100,000 times. I'm not going to go through it again. If you just, you know, play and pause and whatever to see how I'm doing it. If you haven't done it before, that's fine. But yeah, I don't feel like explaining myself yet again on how to do control shapes. It's pretty straightforward. So yeah, watch and learn. Okay, to cap off this little foot rig, I want to talk about just one limitation that this rig has at the moment. Now, if the legs had stretch enabled, it wouldn't really be an issue, but because we haven't built in any stretch into this rig, this is a sort of solution to one little problem with this rig, and that is when the foot starts to pull away from the control setup. So, you know, the foot is still connected to the legs, so they can only go so far, right? You start to get the rig sort of breaking apart. Now, this happens with any sort of IK setup that doesn't have stretch. So we need to figure out a way to quickly avoid any weird disconnects, if anything. It just mitigates it. It doesn't get rid of it completely, but it does help to keep it all in one piece to some degree. So what we can do, I'm going to disable the deform area. I'm going to add a copy. So with these mechanism bones here, I want to add a copy location to these foot bones here, the ones that are driving the deformed bones at the moment. So I'm going to add a copy location to the IK. So I'm going to select the IK bone here at the leg, add a copy location, and I'm going to set it to the tail of the bones. Okay, do the same thing this side, copy location, set it to the tail of the bones. So at least then the bones will actually stay put with, the deformed bones will stay put with the rest of the rig. And finally, just to add a little bit of extra personality to this, I'm going to add a damped track to this bone as well. So a damped track that tracks it to this pivot here. So I'm going to add a damp track, select that bone, select this bone, damp track. And the nice thing about this little setup is that when you pull the rig away from the body, at least you will have an idea that it's overextending. So now the body will kind of stretch the foot down, like it's being pulled down by gravity, like so, which is kind of nice. The rest of the rig still works along with it because of all the parent-child relationships, so it's all working exactly as you expect still. But now we just have a little bit more finesse with that control. So you know, the foot will actually stay put, or the foot controls, or the mechanism bones driving the deformed joints will still all kind of work together. So yeah, now let's inspect what we got. Let's just disable all those mechanisms just for now and see what's going on. So now we have our global controls for the feet. They're all doing their thing. We have the heel pivot on the ball end of heel. We have the banking that's working exactly as we want to. We have the toes working independently, so you can actually manipulate those if you have to. And then we have our pivot, which is really cool. And that's all working in conjunction with the FK-IK setup. So if I turn that back on, let's bring back some FK controls. Let's get this guy posed up, get that heel up, move that foot forward. And you can see that the FK controls are there. And now if we were to switch it, because we've already set that up in the previous video, that's all working exactly as you were. And you can see it's working independently. Switch it back, and the IK is working. Perfect, that's exactly what we need. And that's it for the foot rig. And just to make sure that the right side is working as well, let's just disable those rotations a little bit. Let's go to the right side, do the same thing. Move it forward, sick, noise. That's working. That's working. Banking's working. And of course, if we switch over the FK on the leg, that's all working as well. And that's it for the foot. So in the next video, we're going to talk about how to rig up the hands and fingers. It's a lot simpler than the foot rig, that's for sure. And then we can cap off this series by rigging up the face and neck. So we're getting towards the end game here. Most of the body's been rigged up. It's just the face and hands at this point that has to be done. So I'm looking forward to those. Again, quite a complicated little setup here, but the final product is really, really worth it. So if you find yourself fumbling, don't be afraid to try again. If you have any questions, feel free to comment in the comments below, and I'll be happy to answer anything you have in mind. Anyway, that's it for today. Thanks for watching. Give it a go, as I said. So I'm just going to say catches and have fun. Cheers.